Hi, today I'll be going over extra credit return to libc. So let's go over documents. So given the buff size, we have set it as 200. So you will have to put it on the exploit. Relib. It's 200 right here, and I've already replaced all the buffer size as 200. So once you do that, you will have to go ahead and turn off the randomization. To do that, you basically just set it as 0 and open up the terminal. Set it to 0, and then we also have to configure the bin /sh, copy, paste, and then next will be red slip, which I already replaced the buffer size as 200 as given by professor. Once we do that, we have to change the ownership to root, so root, and then compile the program. Go ahead and compile this, and we also have to make sure we change the buff size over here as 200. And then we have to go ahead and change the ownership of the file. And once we do that, we can exit it out of the root. And then that's basically the pre-task that we have to do. So let's go and do task 1. We basically want to go into a debugger mode and trying to find addresses out of the relib file. So let's go ahead and do touch bad file. Basically create a bad file. When you do touch, you basically create the file, and you copy this, paste, and then you're basically debugging this file. That's basically the order, and then we do run, and then we go ahead and retrieve the system address, which is right here. You have to note it down, and then the exit address, which I have already noted out into my exploit. So the given was some address, and this some address from the system will be from here, and then the exits will be from here. And then we can also go ahead and find out the buffer size by going to this symbol, BOF. Or we have to do it another way. So still we have to go to the debugger, but let's see, GDB, instead of -p, we just go ahead and do readslib, which is the file, and then we go ahead and do this symbol, BOF. Oh, I spelled it wrong. And then this is basically elements of the file, and then you can see right here, this is what we're looking for, EBP. This one converts to binary, will basically be 228, and that's what we want. So hex to decimal. So when we convert, that's 208. So we have to note down that 208, and whenever we switch to different layer from system to exits to bin/h, we have to increase basically 4 decimal. So when we go on to the system, 208 increase 4, it will be 212, and then 216, and then 220. There's a 4 decimal in between. So once we do that, we basically will be able to get the number, and the only address that we need is from the bin/sh. So to do that, we go ahead and quit this and continue following the lab. So we have to go ahead and make my shell equal bin/sh. So let's go ahead and do that, and then check on the environment grep. Make sure your my shell equals to bin/sh, and then we basically just make a file. You can name whatever you want, compile it and run it. In my case, I have it as called tester. So compile it. You have some warning, that's fine. Let's go ahead and run it. So this right here, it's where the address that you should input, the only address left that you're supposed to put in. Of course, each address starts with 0x, and then you just copy and paste the remaining. Compile it, and then task 3 is basically have you compile this and then run the program and see what you get. So if I compile, let's see, what's it called again? Exploit C, and then we run exploit, and then we also run relib, supposed to get root. So this means I have root. To triple check, we do ID, and then you'll see EUID roots right here. That means you're at the root. And in the different version, it's now asking we have to comment out the exits to see what is necessary. So let's go ahead and try that. So let's exit it out, comment out the exits, save it, recompile it, and then do ID. Everything looks fine, but when you type exits, you'll see a segmentation fault. So exits is actually fairly relevant because you need from the beginning, in the middle process, and the end. So it's fairly important. And then the next process is asking if you can change the name of the root lib, and then recompile it and see whether it works or not. So let's go ahead and do that. So let's go ahead and change the name of the file. To be new. And then go back and basically recompile everything, but with new in front of the file name. So we have to go to root, and then copy the compiler, paste it, remember to change the size to 200, and then new. Once compile, we also have to change the ownership. New. Okay, now we exit out, and then we basically run it again, and you will have this error, cannot be found, and that makes sense because you basically change the you can see it right here. The bad file remains the same, but if you change the name of the documents, you basically messed up the whole thing. Let's go ahead and reinstore this because we still need it for the final task. So go ahead and change it back, and then recompile it. Just remove new. Just in case, let's go ahead and test it out. Yeah, now it's back to normal. We can now access roots once we've changed the name back. So, oh, still segmentation faults because I still have the exits coming out. So let's go ahead and uncomment this, and then rerun everything so we can proceed to the next task. Okay. And then this task, you basically want to turn on the randomization. So let's go ahead and do that. And then let's rerun the whole thing. When we turn on the randomization, basically prevents this overflow occur. So there's a segmentation fault. So that's that. And let's go ahead and let's go ahead and turn the randomization back off, and then do the defeat shell countermeasure and see what's the effect. And then we have to actually rerun the whole thing again, basically recompile the program, and so on. So all the address and buffer size, we don't need to do that anymore because that's basically done. We just need to recompile, and then change that, and then exit, and then we go ahead and compile the exploit, run exploit, and take a look at the ID. So over here you don't get to see the EU ID, so that means there's no roots, so basically failed. because the defeat shell countermeasure is enabled. So that's basically it. That's the entire lab for the return to lib. Thank you.